In this experiment, you'll be building a circuit using a breadboard, and then you'll use your circuit to conduct a Coulometric titration with arsenic trioxide. So in this experiment, you'll be using the breadboard, which is right here in front of me. If you notice that there's columns that are labeled A, B, C, D, E, and then F, G, H, I, J. There's a couple of things to note about these letters. So the columns E and F do not have the same voltage unless you connect them with a wire. But if you put something in this A and B, that would have the exact same voltage since they are in the same row. Now if we move over here to the columns that have the plus and minus, the red and the blue, those also have the same voltage per row, but also have the same voltage in the column. So the column that is labeled plus would have the same voltage all the way down. So I'm going to just explain the rest of the components of the circuit before I actually begin building it. So the first thing you'll be installing on your breadboard is the potentiometer. And the potentiometer is what you'll be using when you're adjusting the voltage of your circuit. You also will be using op amps to build your circuit. And these are what you'll be will be controlling the current throughout your circuit. You'll construct your circuit with some various resistors, and that will have different resistors depending on the colors located on the top bead. You'll come to lab and have a box with some wires in it. And all the wires are equivalent. The only difference is their length. So as you notice, this green wire is much longer than the brown wire. They function the same on the breadboard, they're just different in length. To take your measurements, you'll be using the voltmeter and the alligator clamps, which you will clamp on to the various components of your circuit. So we are first going to turn on the breadboard. Make sure it's plugged in. And you are going to want to set your voltages to equal but opposite amplitudes. So if you notice right now, it is set at 15.06 positive voltage and negative 15.14. You're going to want to adjust these voltages until they have a magnitude of 12 volts. So to do that, you have the positive knob and the negative knob. Just go very gentle because it is quite sensitive. Okay, if you notice, I now have a positive voltage of 12.09 and a negative voltage of 12.05. Once your voltages are adjusted, you can turn off the breadboard. Whenever you are installing anything on the breadboard, you want to make sure that the breadboard is off. And when you are taking measurements using the voltmeter, you can make sure your breadboard is turned on. Otherwise, you will not have a reading. I'm going to install the potentiometer, which is this. Now there are 3 pins that you might notice on the potentiometer. The first pin is the input pin, the second pin is the output pin, and the last pin, which is the one that is closest to the knob where we will adjust the voltage, is the ground pin. Now you can install this potentiometer anywhere on your breadboard, but I would highly recommend doing it closer in the upper right-hand corner because that's closest to your voltage knobs here. So these are the voltage knobs. This black one with this tree-like symbol is the ground. This is a positive 5 volts, a positive 15 volts, and a negative 15 volts. Okay. So to install it, you just press down. Okay, and now I'm going to connect the input voltage. First I'm going to connect the ground voltage to the ground, the black knob right here. Sometimes I like to prop up the potentiometer because I forget the exact locations of the pins. Okay. So you do this. And you might need to unscrew the knob up here a little bit. You want to make sure you have enough metal exposed on your wire so that it touches the metal of the ground knob here. Okay, and so to tighten it, you can just screw it down. Now I'm going to just connect the input voltage to the +5 voltage. I'm just going to demonstrate if you need to expose a little bit more wire, you can use this wire stripper here. And you just clamp down and you just gently pull. And that will remove a little bit of the coating of the wire so you can have more of the metal exposed. Okay. And this is going to connect to the +5. All right. I'm going to just push this back down again. Or actually, now I'm going to adjust the circuit and get a current of 100 milliamps. So when I'm taking a reading using the voltmeter, I need to put sort of a pigtail wire into the breadboard so I'm able to take a voltage reading. So I just straighten out a wire like so and place it in the breadboard so one of the ends is sticking vertically up. So I put this one in the output. Okay. Now I'm going to take my first reading. If your wire is disconnected like this on your voltmeter, you can just plug it back in. So the red wire can go into the red spot. So when you are building your op-amp circuits, you're going to be using various resistors, and each resistor comes with a different value of resistance, which you can determine by looking at the different color stripes on the top of the blue bead of the resistor. These different colors correspond to a different resistance value. However, I think it's easier to just use the voltmeter to measure the resistance. So all you have to do is take your two clips and you connect them on either side of the resistor. I'm just going to set this down. And then on your voltmeter, you need to switch the dial to be read. You need to switch the dial to ohms. And this will give you an accurate resistance value. So this particular resistor has a resistance value of around 52 ohms. We're going to be measuring the direct current using the voltmeter. So when I take a measurement, I'm going to turn the dial to the left here where it says VDC. You're going to connect the black wire here to the ground up top. I'm going to connect the other wire to the little pigtail that I put in the outlet row of the breadboard. Okay. So once you get everything connected, you can now turn on the breadboard and you can take a voltage reading. So if you notice right now, I have a voltage reading of 1763. So this is in millivolts. If you just want the reading in volts, you can just switch it and it's 1.76 volts. Okay. All right. To adjust your voltage, if you notice there's this little knob on the edge of the potentiometer, you are going to take this screwdriver and it fits into the potentiometer here, and by twisting it, you can change the voltage. So right now I am twisting this clockwise and my voltage is decreasing. Go slow because it is quite sensitive. And if you are still not getting a voltage reading, because sometimes the potentiometers are turned all the way right or left, so you might need to test it out to see if it is at its extremes. If you do this for a while and you have everything connected and you're still not obtaining a reading, you can just turn off your breadboard and you just want to double check that all of your connections are tight. Once you have completed your circuit, make sure that you save it for day 2 of the experiment because you are going to need it for the Coulometric titration. When you get to lab on day 2, you will need to prepare a starch indicator. You only need one starch indicator per lab bench, so just coordinate with the people around you to prepare this. So here is an example of what the completed circuit will look like. I just wanted to point out where we are connecting our flask to our circuit here. So what I have done is I have taken out the load resistor and I've just pushed it off to the side. And in the place of the load resistor, I have placed 2 leads that are connected to these alligator clips which connect to the electrodes which are in our flask. Okay. So the color here in our solution is what will you obtain when you reach an endpoint in your titration. You want to aim for a very faint light purple color, and you always want to make sure that you start your titration at this purple endpoint because you will be adding a very specific amount of arsenic trioxide. So here I am showing what the color of the solution will look like when it is at an endpoint. The color you're aiming for is a very faint light purple color. When you're doing your titration and trying to determine the color of your endpoint, it sometimes helps to place a white piece of paper, like I have done here, underneath your flask so you can more easily tell the color. Otherwise, you could have a beaker with some clear solution for comparison purposes. I'm now going to show you how the entire color change of the solution here. So as I already stated, we are beginning at the endpoint, which is this purple color. Okay, so I'm going to turn on the stir bar here. You want to make sure that the stir bar is stirring evenly and consistently, but not vigorously enough where it's creating a tornado. And also you want to make sure the stir bar is not hitting the electrodes, which are here. Another thing to note is that you want to make sure the electrodes, which are at the end of their glass of the case here, are completely submerged in the solution. Otherwise your reaction will not happen. Okay, so I'm just going to drop a few drops of my arsenic solution. Again, the circuit is off at this point. I'm going just very slowly. I'm going to maybe do 2 more drops here. Now my solution is back to being clear and colorless. So now I'm going to turn on my circuit, and if you are doing this with your diluted arsenic solution or the unknown arsenic solution, you want to use a stopwatch, and you want to synchronize when you turn on the power of the breadboard to when you hit start on the stopwatch, because that is when the current is beginning to flow into your flask. Okay, so just for demonstration purposes, I'm going to hit go. Now, if you want to make sure your circuit is working, you can look over, and this electrode over here, you can see is producing hydrogen gas if you look very closely into the flask. There is some gas coming out over here, and this electrode here is producing the iodine. Now I'm noticing my solution is starting to turn more of the tan color, so this is when I'm going to be ready to hit stop on my stopwatch and turn off the circuit, because it's getting close to the end point. All right, and I hit stop. So as you can see, it's a very faint light lavender color. And so this is the procedure you will repeat throughout your titration.
Now I'm going to demonstrate how to calibrate the pH meter. And this is a very similar pH meter to the one that you'll be using in the CV experiment. So here's the pH meter. And then we've got 3 solutions that we will be calibrating to, 4, 7, and 10 pH. So to get started, you'll log into the computer and then go to the Logger Pro software and then wait for that to load. And you'll see the pH is down here in the bottom left-hand corner. So to calibrate the pH meter, you're going to want to go to Experiment and then scroll down to Calibrate and click on Lab Pro 1 CH1 pH. That will bring up the Calibrate button. So you're going to want to click on Calibrate Now, and then down here in Reading 1 value, you will enter the value that you're going to start out with. So when you're calibrating the pH, you're going to need to start out with 7 and then go up or down from there. So to keep things simple, I'll do 7 and 10. So we'll start out with 7, so 7.0, and then we can take out the pH meter. So you'll unscrew that. And then before you put it in the pH that we're calibrating it to, you need to rinse off the tip of the electrode with deionized water. Rinse it pretty well so you can get off any residual cleaning solution. And then you're going to want to take a Chem wipe and just touch it to the outside to get off the excess water. Make sure that you don't touch the actual electrode with the Chem wipe. So after you've got that, you can go ahead and unscrew the lid on the pH 7 buffer and then place the electrode inside that and mix it around. And then as soon as the voltage here on the screen has settled, you can select Keep. So right now it looks like it's about 1.63 voltage, and we can keep that value. So you'll just click Keep. And then you're ready for your second reading. So for this one, we're going to do pH 10. So I'll enter in 10.0. You'll need to remove the electrode from the pH 7 buffer. Rinse it again with the deionized water to get all of that buffer off of our electrode. Using the Chem wipe again, you'll need to touch the outside of the electrode, but not the actual tip, because that's where the readings happen. We don't want to damage or scratch it. And then you are ready to place the electrode in the pH 10 solution. So you can place that in the solution and then wait a little while for that voltage to settle. You might have to stir it a little bit. That's usually what helps to settle it. So we're stuck at about 0.89 volts, so that's constant, and we can keep this value as well. So that's all there is to calibrating the pH meter, and you can click on Done, and now your pH meter has calibrated. And as you can see down here in the bottom, it's about 10, and that's what we would expect. So after you've got this calibrated, you can rinse it off one more time into the waste with DI water. And then touch the outside again with a Chem wipe and place your electrode back into the cleaning solution. And then twist that up. So now you're ready to use your calibrated pH meter to study the pH of the arsenic solution. So what you need to do is weigh out a dry amount of arsenic in a beaker and then add 15 milliliters of 1 molal sodium hydroxide. Make sure that when you make the sodium hydroxide solution, you take great care when you're weighing out the pellets because they can be very damaging and caustic, can cause caustic burns. So you'll need to then adjust the pH of the sodium hydroxide and arsenic solution to about 7. So you'll do this by adding 1 molal sulfuric acid dropwise to your solution. You can probably add quite a bit at the beginning, but then as you get closer to 7, you'll need to go very slowly and add them dropwise because it's a strong acid and a strong base, and they reach pH 7 very quickly. When you're all done with your experiments, make sure that you dispose of all the liquids in the proper coulometry waste bottle in the hood.